So here we're going to end up reaching this point where you've got your ESP8266 working wirelessly with the debugger. So the first step that we've done, and this is optional, but this is to get the basic OTA example and add in some extra code so that we can do our upload and our debugging over the Wi-Fi. So first you'll need to set your SSID and key, and we've done this using the project properties so that it's not visible in the sketch. And then from the example you'll need to do the setup and of course ensure the OTA handle runs as often as possible so that when it tries to connect to do the upload it will successfully connect. So we're going to add in some extra code from our LED.ino, and we're just going to call our LED on and off functions, which we can see here. And these are just checking the last time the LED was either turned on or off and then changing its state. But this allows the loop to continue very quickly. So now we just need to go to our project properties and ensure that we've set our Wi-Fi password, as we're doing it here through the configuration defines. There's more information about this in the description. And ensure to do the debugging you've got the remote transport set to UDP. So this is what actually enables the Serial Debugger to work over Wi-Fi. So once you've done that, you'll need to ensure that you've uploaded the sketch to the board to enable OTA initially, and that'll have to be done through Serial. And to make things easier with finding your board on the network afterwards, we can add Bonjour. And once you've installed that, you'll have an additional service in Windows which needs to be running, as shown there. And then when you drop down the COM port list, you'll be able to actually see your board and just select it from that list, which makes things much easier, especially if it changes IP address or if you're changing around networks. If you don't want to use Bonjour, you can add a local board.txt file with the options specified there, and these are also linked in the description. And this means that you don't need the additional discovery service, you can just hard code which board and port it goes to. So we've done our initial upload now, so we'll go and actually enable some breakpoints in the debugger. So if we enable a couple of breakpoints as normal, and then we'll have to do our build and upload, and this will be over the air. So because we've got our board selected with the IP address, this will automatically detect that and do the upload using the OTA functionality. So at the moment you can't quite see it, but the ESP light is flashing away as it uploads, and then when it's finished it'll try and connect, but you may need to wait for your board to actually attach to the network and then connect the remote network port. Now we haven't set any expressions to populate this window, but as you can see in the code, we have actually output a message which we'll see shortly. Now if you do have it attached by serial, you can also go to the other menu and open that serial port. So here that's opening. Now we can see it's fully connected, and we can see our LED is on message in the network window, and that's done using the Microdebug.sendUserMessage code, which you can see here. So as you can see, we can stop on the breakpoints, and all of the usual plot charts and further Serial Debugger functionality are available over UDP. So please see our other videos and documentation for further details on that. And this is also available on the ESP32 platform as well. So now you can do your upload and your debugging wirelessly.